Hello students, welcome to my YouTube channels. Today our subject is the strength of material. So I taken one very simple derivations and one problems I will solve. For the UG strength this is very important and very simple. You can get the marks very easily. So what is there here? So bar of the varying cross section. They will give various cross sections bar. Like they given first bar D1 dia, D2 dia, D3 dia, length L1, L2, L3 and both side axial pull force will be P. P kilonewton or Newton, whatever they will give, that only we have to consider. So first we will derive here. What type of question they will ask here? They will ask find the stress in the each section, find the total elongation, like these things they will ask. So we will derive here all the formulas here. So before this we should know what is the elongations of the any one section. Suppose one section is there. Suppose this section is fixed, and one pull force P will be there. They will ask what is the elongation of the particular bar. So once pull force will be there, definitely some elongations will be there. Some elongations, negligible elongations will be there. That elongations we are assuming delta L, and this length will be L. This length will be L, and this body Young modulus they will give, some Young modulus will be there. So they will ask what is the elongation of the particular bar. So elongations how will write? So we know the Hooke's law, no? Hooke's law what they are telling? Stress is directly proportional to the strain on the proportional limit. Stress is directly proportional to the strain. So what is stress? Already we discussed previous video. Internal force per unit area. Internal force per unit area. If this is proportional, make the equal to, then what will come? Young modulus. If remove the proportional, it will come Young modulus. And strain is nothing but change in length to the original length. Change in length to the original length, that is called strain. So what is strain? Against the deformations. That will be the strain. And stress, internal force per unit area. If you are applying the force, internal force generate inside the beam or bar. So that is called internal force per unit area. Now what is the elongations here? So we go the cross multiplication. What will come here? PL by A. This will come E here. So what will be there here? Elongation. What is delta L? Nothing but here elongation. Delta L will be the elongations here. So PL by AE. P is applied force, L is length, A is area of the cross section, E is Young modulus. So okay, suppose one more formula if you want to modify na, you know stress equal to P by A. So P by A is there now, P by A. This P by A you can write stress, then L by E. This also nothing but elongation. Somewhere we'll use also like this, stress into length by Young modulus is nothing but elongation. So see here P by A. P by A is nothing but stress. P is stress into length by E. So this also known as elongations. Okay. So this is the formula we will utilize here. Based on this formula and all, we can solve these questions. Also I wrote this, I will solve now. First I will derive this. Okay. So listen here. First D1, D2, D3 the given. So area will become different. No? So first you will find area. Area is equal to nothing but pi by 4 D1 square. A1 nothing but pi by 4 D1 square area. Then we will go the area A2. Nothing but pi by 4 D2 square. Similarly A3 will be nothing but pi by 4 D3 square. So this is the pi. Okay. Pi value directly will be there in the calculator, or pi value will be 3.14 also. Okay. So area we know now. Area we know. If we want to stress for the particular one, first block, this called symbol will be the stress. Stress nothing but P will be same for all the block, because this axial load here. This load will be nothing but axial load. So P will be same for all the blocks. So what will be there here? Internal force per unit area A1. What is the stress 2? P by A2. Again stress 3 nothing but P by A3. So these are the stress developed in the particular beam. These are the stress developed in the particular beam. These are the stress developed in the particular beam, individual stress. Each section, what is the stress they may ask. Now if they will ask elongation. Now this I will rub it. So elongation formula, you know, PL by AE, how this coming, I explained here now. Now let us see here what is the elongations of this body. That means total elongations of the body. Total elongations of the bar. Total elongations of the given bar. So what is the total elongations? Elongations you suppose you take delta L. It's called total elongations. You write here also bracket. This is total elongation, nothing but delta L. So what is total elongation? Elongations of bar 1, bar 2, bar 3. So we'll write delta L1 plus delta L2 plus delta L3. That is called elongation of particular bar 1, bar 2, bar 3. Now already we know the elongation formula. What is? PL by AE. PL by AE. P internal force, L is length, A is area, E is Young modulus. So Young modulus generally they will give same. If you will give different, we'll let E1, E2, E3. But generally same material, so Young modulus will be same. So here P will be same. So L1, A1 will be different. Plus, then you write P will be same. L2, A2, E. Plus PL3, A3, E. This is the total elongation. This is nothing but total elongations of this bar. This is the formula. Also one more steps if you want to write P1 by A, what we'll write here? Sigma L1 by E plus sigma L2 by E. Or you can substitute value there itself, nothing wrong. Both are same. Then sigma, that is called sigma 1. This is called sigma 2 because you know stress also develop different for different cross section. L3 by E. L3 by E, just space. A3E here, sigma 3 L3 by E. Okay, so this way also you can write. This is the total elongation. This is called total elongation. So this is the total elongation for you substitute either here or here. So this is the very simple concept. So if you know the derivation, each part, see area I know, A1, A2, A3, stress I know, then total elongation. So this much they're asking. So come this problems. What the problem they're asking? So what this problem they're asking? So here problem, given problem also will, given diagram will be there. But figure shows, you know. So figure I will give here. What is given figure? Similar like problems I taken, what derivations I did. So dimensions here given. Dimensions here given. So that only I will write here. Dimensions the given. Force the given 40 kilonewton. Either they will give Newton, either they will give kilonewton. Whatever they will give, we can write here. So dia they given 30 mm. 30 mm, that is D1. T2 they given 20 mm. This is given diagram. D3 nothing but 32.5 mm. Length they given how much? 180 mm. 180 mm. This length they given 260 mm. This length they given 160 mm. 160 mm. The length they given 160 mm. So this will be the given diagram. This is the given diagrams. Okay. So everything is the given here. Now what they're asking here? So on the figure bar consisting 3 sections. How many sections? 1, 2, 3. So D1, D2, D3, 3 sections. Then you can write this is L1, this is L2, this is L3. Dimensions they given. Dimensions they given. These are the 3 dimensions they given. Find the stresses in the 3 sections. That means we have to find out sigma 1, sigma 2, sigma 3 here. And total elongation of the bar. Total elongations of the bar. Of the axial pull, P they given. That P, there no P given 40. And E given same for each block. Then see what they're asking here. To find the total, find the stresses in the 3 bar. So see here. Stresses formula. So for this what we need? We need the area. So directly write, okay, stresses on the 3 bars, what is? Sigma 1 is equal to P by A1. So what is P? 40. kilonewton means, kilo means 10 power 3. So Newton came. Now area what is pi by 4, what is d1? 30 whole square. So if this value you will calculate, what unit will come? See here, this unit will come Newton, area is mm square. So unit will come Newton mm square. So what is this value will calculate? Newton per mm square. So this value will calculate and I'll tell you now what is the value of this. Okay, you have to use the calculator and you have to calculate. Okay, so this value is there, sigma 56.589. 56.589. If you use the calculator, keep the calculator in degree mode and calculate stepwise. Okay, so this the value will come for the stress for one section. Now similarly stress for the second section, same formula I am going to write. What is P by A2 here? So P is equal to nothing but how much? 40 into 10 power 3 divided by pi by 4. What is dia? 20. So 20 whole square. So this value also will come Newton per mm square. This value also will come Newton per mm square. So sigma 2, that means 127.324. This is the Newton meter square. Sigma 2 came. Now sigma 3 will calculate. So now I will rub it this side and will calculate all the parts. So sigma 3 now. We'll write the formula for the sigma 3. What is? P by A3. P is equal to 40 into 10 power 3, make the kilonewton to Newton, and pi by 4, what is dia? 32.5 whole square. 32.5 whole square. So this value will come, already we calculated here, 48.217. 48.217 Newton per mm square. This is the unit for the stress. So first part over. Stresses on the three parts over. Now what they are asking? Find the total elongation. So total elongation, this is the formula already we have. So we will write this formula, last formula. What is last formula here? We know that total elongations of the given bar is delta L equal to sigma 1 L1 by E. See, you can write PL by P L1 A1 E1 also this, but here P by A1 already value we have. See this value we have. So directly we will use this formula, plus sigma 2 L2 by E plus sigma 2 sigma 3 third section sigma 3 L3 by E. So now 1 by E also you can take common, no? So what will write here? 1 by E, what is? 2 into 10 power 5, take common. What is sigma 1? 56.589. What is value we calculated? Sigma 1, 56.589. What is L1? Into 180. Into 180 plus. Now this part I will rub it. Now second one, what is? Sigma 2 already here, 127.324 into L2 how much here? 260. So you will write here 260. So little space need, no? Not looks good. Okay, again I'll write this. We'll take this part, this from here. Okay. So what we'll write here? Stress will be, okay, first 1 by 2 into 10 power 5, then 56.589 into 180 plus 127.324 into second is how much length? 260, then plus sigma 3 48.217 into 160. So now we got, check it again, 1 by E. We taken common because E is same. sigma 1 L1. What is sigma 1? 56.586. What is L1? 180. Now sigma 2, 127.324 into 260. Then sigma 3, that is stress developed in third section, 48.21 and 160. 260, 180. If you will calculate this, it will get the total elongation. So how much we got this? We'll see this value. Total elongations we got 0.255 0.255 mm. So this is the your answer. This is your answer. This will be the answer for this, and this also first answer, another answer, and this will also. So stress develop in the 3 section, 1, 2, 3. Then total elongations of the bar. This is the total elongations of the bar. So this is the very simplest problem. Simple problem. If like this question solved in a one question, since strength of material, first unit you can solve easily. Okay. So okay students, watch this video and share this video to your friends where required, and subscribe the channel. So my YouTube channel is Dr. Ashok G Make Solution. So okay, so go through this, and this formula, derivations and basic concept I will give link in this video description, so that also watch. Okay, okay friends, thank you.